All right, let's have a look at this. So this is the work, and we're gonna say, where is it? Right here. Okay, guys, so this is for my D class because you didn't have enough time during the lesson. C had plenty of time, but you guys were a little more social, so we had less time. So you have to watch this and complete these notes for Monday. So it's the notes we started already, the 5.1 from before the break. We finished up through number 9, I believe. I would like to talk about polynomials. So polynomials are sum or difference of many monomials together. So polynomial examples could be 2x squared plus 3x plus 7. That's a polynomial. It has 3 terms, okay? It's the sum or difference of 3 separate monomials, right? The degree of that is 2, because 2 is the highest power of x. So that's called the degree, the highest exponent in there. The standard form, you just want to write in descending. That means going down, powers, exponents. So it just means that you would have something like, for example, if you had 3x to the 4th plus 2x cubed plus 3x to the squared plus x minus 3. Okay, so something like that has 4, 3, 2, 1. You can be missing one of those, but you definitely can't put the 4 at the end, right? Or something like that, right? Write the polynomials below in standard form, okay? So the 5th power is going to go first. The 4th power goes next. There is none. So we'll put the 3rd power in there, the 3rd exponent. Then I got the squared. That's plus 1/4 k squared plus 8k, and then minus 1. Okay. Here, I'm looking at the a's and then the b's. So it looks like I've got an a cubed first, because a comes before b, right? 4a cubed. The next lower a is an a squared. Okay. And then I've got an a to the 1. A to the 1. It has a b with it. And then this last part doesn't have any a's in it, so it's like an a to the 0. Okay. So again, I'm looking at my alphabetical order. So I'm going to do my x's first. So stick in alphabetical order. We've got the highest power of x is a 3. 9x cubed. Then we have squareds. X squared minus x squared. Do we have any x to the 1s? Yes, we do. There's positive 5 of them. X to the 1. And then do we have any x to the 0s? Well, in this case, we have a few possibilities. X2, x3, 9x3. I've done that one already. You can do this too to make sure you don't miss one of them. And at this point, I would say that I would accept 2 possible answers for this because it depends on the book. It's just that there are no x's here. There's like x0 on this one. So I would say the y needs to go bigger. So you could have minus y to the 4th plus 2. Or I would take it if you have the 2 and then the y to the 4th after that. The important thing is the x's are descending and going down. It's in alphabetical order, so 3, 2, 1, 0 on the x's. Degree for polynomials, 0 degrees called constant. It's a constant. So if I had just like, say, 13 with no x's or anything, that's a constant. Or y equals 2. Remember that constantly was up 2 and constantly never increased or decreased on the graph. So 2 is a constant. Okay? Then you have linear, okay, which is when you have an x to the power of 1. So I had something like a function like this, y equals 3x. That's x to the power of 1. Okay? That's a line. Y equals mx plus b. That's a line. It's linear, so it's a line. This one's going to be a second degree polynomial. Would be, starts with a q. Quadratic. Cubic. Quartic. And quintic. Those are the names. Okay. The number of terms. One term is a monomial. 2 terms is a binomial. 3 terms is a trinomial. And 4 terms is 4 or more terms is a poly. We don't have a special name for those. We just call them polynomials. They're all polynomials, but definitely that one is. Okay. The more specific names are here. Use those if it's 1, 2, or 3. Okay. Yeah. So this is a power of 1. So it's a linear. And it has 2 pieces. So it's a binomial. This is a 5. So it's a quintic. And it's a 1, 2, 3 pieces. 1, 2, 3 pieces. It's a trinomial. This is a constant. And it's a monomial. This is a third degree. Is that the highest power? So it's a cubic. And it's a 1, 2, 3, 4 pieces. So that's a polynomial. This is a 2, so it's a quadratic. And it has 3 pieces, so it is a trinomial. This is a 4th power, so it's a quartic. And it is a monomial because it's only 1 piece. Cubic binomial, for example. A linear monomial. There's an example. Or another example right there. Okay? And that's how we do those. Adding and subtracting polynomials. If you want to add them, you just add them together. So 3x squared plus 1x squared is 4x squared. 11x's minus 5x's is 6x's. A 4 can go with the negative 13 to get negative 9. If it's a minus, you have to change the sign of all the second ones. So here's what I want you to write for the first step. 5k cubed minus 2k squared plus 2k minus 2k squared minus 2x minus 17. Stuff that goes together. The cubes, there's only one of them. 5k cubed It says write it in standard form, so we've got to make sure we write the biggest powers first, right? Going to the lowest powers. Minus 2k squared. Oh, wait a minute. That's minus 4k squared. Because you can add them together, right? And then I got 2k and minus 2k. That's supposed to be a k, I believe. Yeah. So the k's are gone, the k1s. 17, negative 17, I think that's the only thing. Okay, that looks like my standard form, 3, 2, 1, 0, okay? So that's how you do it if it's a minus. Subtract this from this. It means you put them backwards. So the 8b squared plus ab minus 2a squared comes first, and we're subtracting the negative 10ab plus 7a squared minus b squared. So it means we got to change the sign of that second, all the second things. It means that we're going to add on changing the signs of these. And that's the signs we're going to use, is the changed signs. So it means I've got 8b squared plus ab minus 2a squared plus 10ab minus 7a squared plus b squared, which is equal. Let's put all this stuff together. They can go together. The biggest power is the squared. I'll go with the a's first. Alphabetical order. So the a squared, there are those and those for the squares. Any more a squareds? No. So I've got negative 7, take away 2 more, negative 9a squared. Okay. How about a to the 1 power? Any other a's to the 1 power? Whoops. Yeah, right there. So that's an AB. That's not an A. Oh, they're both AB, so that's good. There's a 10AB, positive, and a plus 1 AB. That's 11 AB. Okay. Any A's to the 0? We got A to the 2, A to the 1. We need A to the 0, which means there's no A's in it. Well, that's pretty easy. That's this one and this one. So it looks like 8b squared plus 1 more b squared is 9b squared. And that is in standard form. The a squared, a1, and no a. Okay. These we multiply and we multiply. So that's the way that works, and we would get some answers. For these, we do the same thing. We multiply. I think I did some of these for you guys already, but we multiply, and then we're going to deal with the rest of it in a minute. So let's make it look a little nicer. 2x times 4 is 8x. 2 times 9, negative 18x squared, plus 4. 1 times 4. And 1 times 9, negative 9 is negative 9x. Now, I'm going to take the number in front of the parenthesis and multiply it or distribute it. Negative 2 times 3 is negative 6. And x times x is x squared. And negative 2x times the 11. That's what I'm looking at right now. That one is 2 times 11 is 22, negative 22, x. Now let's see if we can put things together. So the highest power looks like x squared. There's 18 of them, or negative 18, and minus 6. That's minus 24. Minus 24x squared. Don't forget the equal signs, guys. Put them in later if we'd forget. That's the x squared. How about the x's to the 1 power? It looks like we have 8 minus 22. 8 minus 22. $14 minus 14, x, and then what else is there? That's the x to the 2, x to the 1. We got some x to the 0 stuff right here. Right? Is there more x to the 1 power, though? I think there is. Hold on. We got one more x to the 1 power that I forgot here. Right? That one. So we take 9 more off of that. Negative 14, 23. Is that right? Negative 23. Double check me with your calculator. Okay. And then we can do the one that doesn't have any x's with it. I think that's the only one. Now, double check that it's in standard form. It means we got x squared, x1, and x with nothing. Don't forget that this one here means 2c plus 5d times 2c plus 5d times 2c plus 5d. You got a lot of work. Well, you got more steps to do there. You got to FOIL the first one and then multiply everything by the second one. Or distribute this, the third one, I mean. So, boom, 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 boom. 2c times 2c is 4c squared plus 10d plus 10 more d plus 20d plus 25d squared. Right? And then those three things get multiplied together with 2c plus 5d. So I've got 8c cubed. Plus 4 times 5 is 20 c squared d. Let's see, now let's look at this one and this one. Start there. So I'm basically doing this one now, and then I'll do this one and this one. There's some multiplying to do, really. Okay? So 20 times 2 is 40 DC. 40 CD, because it's alphabetical order. Don't put DC, please. 5 times 20 plus 100. D squared. So I did the second one. Now I'm going to do this one times in the end, I should get 1, 2, 3, 4, 5, 6. Because you have 1, 2, 3 times 2. You have 6 pieces. 1, 2, 3, 4. There should be 2 more pieces. And that's this one and this one. Okay? We can put our equal sign back in there. And we're going to do the 25d squared times the 2c, which is, and they're both positive, right? Plus 50 cd squared, alphabetical order. And then the last one is 25 times 5 is 125 plus. It's all positive, I think. 125. And I've got a d squared and another d. That's a d cubed. And now I need to start with my alphabetical order, my c's, and start with my c cubed, I think is the highest one, and it is 8c cubed plus, that was the only c cubed in there. Well, let's see with some c squareds. Do we got some c squareds here? I just see that one. So I'm going to say plus 20c squared d. And then I'm looking at just my c to the 1 power. That's that one and this one, I think. So I got 40 and 50 is 90. No, those aren't the same. Those aren't even the same because the d squared and the d1. So I can't really do that, can I? That's a d squared. So I can't actually put those ones together. I'm just going to leave them. Plus, and I'll do the lowest d power first. Plus 40 cd plus 50 cd squared okay. Remember, we're only concerned about the alphabetical order. C comes before D, so we're dealing with starting with the C3, C2, C1, C1 if there are more of them, okay? All right, and what was next? So we dealt with this one already. We've got no more C's. I'm going to keep going in the same pattern with my D's, right? So this is a 1, this is a 2. Actually, my D's are going to kind of go up because my C's are going down to 0. So this next one right here will be my C with a 0, which means there's no C in it at all. It's just the D's, all right? So I've got a D squared here and a D cubed here. And since I went D1, D2, I'm just going to keep going in that same pattern with the rest of the D2s. 100 plus 100 D squared. And then I've got plus 125 D cubed. All right, is it in standard form? Yes, because alphabetical order, the C starts with C3, C2, C1, and keep going down with the C to C0s, right? And the D's just naturally follow upward here. Right, okay. You should be able to do all of these. Number 8, you could multiply the 3 times both of those first, or you could wait and FOIL together 2 of these and multiply everything with those, and then multiply everything with -3. A lot of steps on that one. Okay. Height of a trapezoid. Trapezoid looks like this. For example, trapezoid was something that had at least one set of parallel sides. But it doesn't have to have the other ones parallel. Okay. And the height was the straight up and down. That's sometimes called the height or the altitude. Okay. And these things here were called bases. What's a base? That's a base. So those are 2 bases. The parallel sides are bases. The formula for the area of this thing was the average of the bases. You take the average, you add them up and divide by 2. You average out those bases and multiply it by the height. So if you know the formula, if I give you that formula on the test, you should be able to just put the numbers where they belong. So it can be the bases, B1 and B2 are right here. And the H, the height, is right there. And so you're going to kind of multiply everything out and divide by 2. So we have the bases, 3x plus 7, 3x minus 7, x plus 5, and divided by 2. And the area will have that multiplied by the H, which is 2x plus 9. 2x plus 9. Okay. So you have to do those out. Do that and check the answers in the answer key. We did some of these on the warm-up. Actually, we did exactly this one on the warm-up. Okay, for example, so look at your warm-up on that. These are not that difficult, but you kind of have to just be careful. An example could be 17, you could see on your test. 3 goes into 30 10 times. I have an x1 because it's an x3 and an x2. Minus 3 goes into 12 4 times. And I have all the x's cancel out, x2, x2. And 3 goes into 9 3 times. And x2 on the bottom, whoops, sorry. And x2 on the bottom. Notice here there's an extra x on the bottom. So we have to keep that x on the bottom. You can't get rid of that bottom x. There's extras on the bottom on that one. Okay. Let's have a look at this one, number 18. 8 goes into 45 times. M1 on top. N1 on the bottom, because there's an extra n on the bottom on that one. Minus 8 goes into 24 3 times. M's cancel. Extra n on the top. Extra n squared on the top, because 7 is more than 5. And there's your answer for that one. So that's pretty doable, really. So 12 over 30, you can simplify it down because I think 6 times 5 is 30. And 6 times 2 is 12. And you've got C8, C2, that's C6 on top. And D3, D1, so that's D2. Whoops, I said D and I put a B. D2 on top. Extra 2 Ds on top. Minus sign right here. 12 goes into 36 3 times. C4, because C2, C6, and D1 on top. Nothing left on the bottom for that second one. Plus sign. I think it looks like there's 6 over 12, which is like 1/2. You don't even need to write the 1, really. Extra C on the top. D's cancel top and bottom. There you go. There's your 16. I'm trying to